So we've looked at a lot of rates of reactions. Now we're going to look at the things that affect those rates of reaction. And so specifically on the molecular level, the things that will affect a reaction rate are the rate of collisions between reactants, so the amount of times that they hit each other, and then the percentage of collisions with the proper orientation, and then also the percentage of collisions that have enough energy, activation energy, in order to trigger that reaction. So really, it all comes down to the collision, and anything we can do to increase the collision rate, we can do to speed up the reaction. And so if we increase the concentration of any reactants that are in the liquid or gas phase, the number of collisions are going to increase, just because there's more stuff to run into each other. Also, as the surface area of reactants in the solid phase increase, and so that's talking about like a sugar cube versus powdered sugar. The powdered sugar is going to react a lot better than a sugar cube will, because you get more surface area, and also an increase in temperature. Really important thing though is not every collision triggers a chemical reaction. So if you've got two reactants, A and B, just because A and B hit each other does not mean that they will react. They have to hit with enough energy, and they have to hit with the right orientation. So here's an example reaction. We have NO2Cl, and two of them are going to react to form NO2 and Cl2. So we can see from this reaction the products that form are nitrogen dioxide and Cl2. That means from these two NO2Cls, those two chlorines are going to have to react with each other. And so if those two molecules collide like this, even if they hit with enough force, enough power, that's not going to generate a reaction, because the chlorine is colliding with the oxygen is colliding with the other oxygen, and nitrogen with nitrogen. That's not going to form NO2 and Cl2. In order for this to react, it would have to hit in this direction, where the chlorines react with the chlorines, and then the NO2s can break off from each other, and so we'd form these products. And so it's about the proper collision. And so the things that we can do to speed up a reaction, like heating them up or stirring or increasing the surface area or increasing the concentration, all of those work because they increase the odds of a proper collision happening. As the concentration goes down or as the temperature goes down, there's going to be less motion, less molecules, and so they're not going to have as good of odds of hitting the right molecule with the right orientation and with the right speed.